Good morning. Today we will begin with the next chapter, that is a unit, verification and validation. So this is a very important thing that you people need to understand and learn. And in earlier syllabus version, software testing, we had a separate course, right? For you people, we don't have a software testing separate course. It has been integrated with software engineering in full length, right? So you people have to understand this particular chapter with more seriousness, okay, from your end, right? So we'll get into unit number 4. Part of this we will include in IA2, and remaining part that will go into IA3. And IA3 will focus on software quality in project management and part of the software testing, particularly focusing on verification, the validation part, right? So with this introduction, okay, that we will get into the coverage, right? And please remember, as a part of the CT assignment, here the PEM model, performance ensuring measures, if you look into that, see we have a industry relevant tool for testing and model based testing, right? For these two, we have given you assignment. One is on JUnit, am I right? Ashish, am I right? Arpita?
Yes, sir.
Right. And other one is model-based testing. We are given a two, okay, thing. Sorry, one we are given state diagram based testing that we are given, and you need to do that one. That will give you hands-on experience on, okay, whatever the theoretical stuff that we are talking in this particular unit, right? With this introduction, right, we will get into our coverage, and today I'll introduce different terminology, background, introductory note. Then slowly we will get into actual practices where you do the testing, right? So this is the first part. The second part, when I talked about the model-based testing, one of the model that we have used was the state diagram, and this assignment is there where in a group you are expected to develop a test script, right, for this, right? And we have used this particular definition. I hope that some of you people, or majority of you people, have completed this particular assignment, right? Arpita, what is the status of doing this particular work? Arpita, Ashish?
Sir, this is almost done, sir. Everyone has completed it.
Okay. I mean, why I'm asking this is that when you are doing that one, there are two things, three things, in fact, remember. One is specification, design specification, that is given here in the form of the state diagram. The behavior of a particular system, okay, is represented here, and accordingly, some group has developed a code and the class file is available to you. Now, you as a tester, wait for a minute, the disturbance because of the railway. Okay, I'll come back, right? Uh, Now, based on the state diagram, some group has developed the code, and you people, right, how to check that one whether the code is written properly or not. That is an experience that you got it, right? Are you clear about this? Are you clear about this?
Yes, sir.
Right. Okay, I hope that one everyone has done this. If any specific people they have got a doubt and all, okay, you people have to initiate the video discussion through the video. Okay, this, and I will further interact with you all people. Those who are interested, okay, please get into that. So this is the model-based testing. Another discussion that what we have done, okay, as a part of the model-based testing, right? Now this 1 minute, let me open. Yeah, right. Yes. As a part of this, we have gone through the sequence diagram. We said about the use case, right? Use case diagram, we said it, and every use case, right, you can represent in the form of, right, scenario, right? And every, collection of scenario makes a use case. And for every scenario, right, these are all possible scenario we discussed. And for a given use case, you'll be writing a sequence diagram, right? focus of the sequence diagram is to, right, understand a given scenario in terms of the different objects that participate in given scenario and how do they interact with each other. So once you know the interaction, once you know the different object participation in this, probably you will be building the test cases, right, to check that one, the sequence in which they interact with each other, to check that one. And we are given one simple example, right? This is the test case, okay, test case. These are the test cases which are designed, okay, at the design time, not during the coding time. During the coding time, the people will take this report and ensure that the expected results, are they getting it or not? They will check it, right? Thus, are you clear about this? I think, Ashish, we have discussed all these things. Ashish,
Yeah, yes,
we have discussed now?
Yes,
yes,
sir.
sir.
Yeah, right. There, almost the majority of the stuff of the testing, right, we have discussed. But there are some other important aspect, right? Okay, that is called condition testing, decision testing, path testing, data flow analysis, and all. Those aspects we'll try to go through that one. But before that, let me introduce the different terminology. Today, it is purely a theoretical stuff, right? So with this introduction of, in fact, whatever that we have done before, okay, I'll keep moving to the next one. All these are important from IA2 internal examination 2 perspective. Please get into that, right? Right. Having done this, okay, let me introduce, okay, begin the theoretical stuff, okay, of, right, towards the completeness of understanding software testing rather than in between getting into basics, right? So now I'll begin introductory note, uh, understanding different terminology, right? We have two terms. I do not get into in detail because already we have gone through some of the software engineering concepts into that, right? So what we will learn here is we understand verification, validation, what do they mean, planning, inspections, right? Automated static analysis, verification, formal method, software testing, okay, system testing, component testing, test case design. Test case design, we know about that. Already we have gone through. Test automation also we have gone through. Okay, based on the state diagram, whatever the test script you write, that is nothing but test automation, right? You write a program and see that one, the program takes, right, the entity which you want to test, feed all the input and take the output from that entity which you want to test and compare the results and tells its behavior, is it working as per the your specification or not. That's what you are doing, like in behavior testing, a model based testing, right? So that's the kind of an automation that you do, and automation can be taught in different format and complexity. That's what, like a simple format that we have introduced to you. So test case design and test automation, that you people have got an exposure for that, right? So let me introduce, so please mute all of you, right? So we will get into the basics of this. Look at that, very interesting, okay, the statement being done by some people, right? As we strive to implement the new features of our application, there is one thing we can say with an absolute certainty, that at the same time, we also introduce new defects. True, right? There are terms called defect, there is something called fault, bug, a different domain. Okay, people, they use different terms and all, right? We frequently use defects also, right? So defects are nothing but, okay, you find a flaw somewhere, right, which, okay, makes you to deviate from the standard, okay, expected output that you are supposed to get it. You are supposed to get the output 10, you get, okay, 10.2. Okay, it is because of the defect. Defect is at the seen at the physical, okay, level. For example, right, the tube light or the bulb doesn't glow, okay, because there is a defect. What is the defect? Maybe there is a loose connection, or there may not be any connectivity there, right? Connectivity may not be there in the plug, connectivity may not be there in the holder or whatever that is there, right? The physical level, whatever you find, we call as a defect. You are supposed to write AND, logical AND in the program. You are written OR, right? Program doesn't produce output, correct output in all the cases. So that instead of putting an AND, you put the OR. That place, at a physical level, whatever that we see, right? That's what we call as defect, right? So your objective is to learn to test and test to learn, both. Learn to test, right? I give a program specification, I give, will it work as per the specification? How do you do it? Right? There are two ways. On the paper also you can do, and we call it as a code walkthrough, right? Okay, think for a moment you are a processor, right? Take a possible input, imagine different possible input, that's called test cases. All possible input that you can give it to the system, right, which produce a different categories of an output, right, that you need to visualize. That's what learn to test needs, different kind of an idea what all the possible input it takes. A simple example, let me write it on the whiteboard here. Hope the board is visible now. So I'll write, okay, if x is the age, the greater than 18. If x greater than 18, if statement, right? Now issue insurance, otherwise don't issue the insurance. Is the screen visible to you, whatever I'm writing? Ashish, Arpita?
Yes.
Right, now look at that. Is okay, if x greater than 18, issue the insurance, otherwise don't issue. Right? Now what all the possible input I have to give it for this? Right? Look at this. I'll change the color of the pen. Right. So when you look at the possible input, what all the possible input x will take, now look at that. It is okay, plus infinity to minus, I mean, okay, either direction you can see, right? I'll say for simplicity -2, here -1, right? Okay, 0, 1, 2, okay, it gets into, then I'll take you up to 18. Now here I'll write 17, right? Then I'll write it again 19. Then this end infinity, right? This end, okay, it goes to the other end, which you cannot imagine, right? Beyond imagination. Now, what all the possible input I have to give it to check this, right? Please look into one of the technique we call, okay, partitioning, equivalence partitioning, right? For example, x greater than 18, x greater than 18, this is the one partition. Hope you understand. X greater than 18, right? Whether I take 90, whether I take a 19 or whether I take a 20, 21, 22, 100, 200, 10,000, 50,000, whatever it is. Okay, they should produce the same effect because they're all greater than 18. Are you getting it? So I call it as a one partition. Now I'm telling you what is that I'm demonstrating to you is that learn to test. In order to test that one, you should know all the possible input that a system takes. You need to visualize that. Once you can visualize, then there are different strategies, different theories we will study. One of the theories, equivalence partitioning, I'm telling you. Okay, ahead of time, I'm sharing with you. Later, I will discuss once again on this with more examples and illustrations better. So one partition, okay, is like this, where 19, 20, 21 in this case, all produce the same kind of behavior, right? Now look at that, 80 greater than 18, right? So now what I do is, right, 18 is different. 18 and below this is different, right? This is I call as a partition number 2, right? Ashish, do you agree with this? Right?
Yeah.
Right.
Yeah, yes, yes.
Right. Now look at that. Now it is enough, but there are many lot, okay, in-depth discussion we do later, right? This is not sufficient, but right now we'll assume that this is sufficient, we'll get into. It is not complete. I say sufficient for the today's discussion, but it is not complete. Okay. Now look at that. I'll take one from this input, any representative of the partition P1, one from this. So how many test cases are there? I'll call this as the test case T1 and I'll call test case T2. Okay, I have to give input 1 from this, anyone, and anyone from this, and if the program works with whatever that is required. For example, I'll give a test case T1, it should ensure that the license is being issued. Right? Okay, when I give input T2, right, T2, any input from this, okay, it should not issue the license or insurance, whatever that is there. Right? So now look at that. When I was talking about the defect and all, here you're written greater. Okay, sometimes people may write greater or equal to. Right? Okay, how do I find this fault? There is likely that this is going to happen. This is a defect, this is a fault. Right? How do I detect that one? So what it speaks about that is the boundary value analysis. Wherever boundary, you find a boundary, 1 minute, I'll change the ink color, right? So that is a clarity in, okay, what I write on the whiteboard. So people, I want to detect whether a greater symbol is properly used or not. So in that case, test T1 and T2, they are not sufficient, right? The greater or equal to, okay, this is different. That means it becomes part of this get extended here, right? The behavior is different. Instead of greater equal to, if they do something different, how do I discover that one? So boundary value analysis. See, look at the previous one, blue color partition, whatever I have done, right? The boundary value analysis is you take the input, okay, just at the boundary, right? That means I'll take 18 also. Now assume that greater or equal to is not being used, it is only greater, right? I take 18 also, I take a 19 also, that is 2. I call it as T3, right? I call this as, okay, T4 to ensure that, okay, it's only the greater symbol is being put, right? Greater, right? This, right? So 18 and 19 boundary value I put it, okay, when I give 18, right, okay, it is same as T2. When I give 19, it is same as T1. I'll ensure this, right? So minimum, okay, there are 2, okay, test cases, and you can add little, okay, this to ensure the concept of a strategy of boundary value analysis. Every boundary adjacent to the boundary, take the value and ensure that operators have been put properly, right? Is that clear? Is that clear, Ashish, Arpita?
Yes.
Now, what is that I was speaking all this time? It is learn to test, right? Learn to test. And one more thing is being said by some people, right? To be clear is professional. Now, what I'm telling is when you build a test case, when you visualize possible input, there has to be clarity. What kind of clarity, right? A particular test case, what exactly it is focusing in a given product. For example, what is an objective of test T1? Objective of the test T1 or the partition P1 is to issue the insurance or license. That particular feature of the product which issues license to the user, right, that feature is being tested. Whereas the test case T2 objective is, or objective of the partition P2 is to ensure that when the product will reject issuing license or the insurance. That is an objective. So what is an objective of the test case T1? What is the objective of test case T2? Right? This is, okay, the concept learn to test I was sharing with you all people. And we have introduced 2 strategy. One is equivalence partitioning, other one is boundary value analysis. Ashish, note down this question, update in, okay, our, okay, in class question bank. In class question bank update, right? Right? Explain the following term with example. Explain the following testing strategy with example. First one is equivalence partitioning. Second one is boundary value analysis. But anyhow, we will take more example later whenever it comes in a particular order and sequence. Noted? Ashish, noted? Arpita?
Sir, the second one?
Boundary value analysis.
Yes, sir.
Right? That's.
Yes, sir. Got it.
That's good. Okay, update it in previous class, whatever we discussed, all that thing. Question also you need to update. Right. Let me get into some of the terms that we use. So when you look at the whole product development, right? So it takes its own compartments. One is problem space, other one is solution space. When you look at the solution space, feature, use cases, design, test procedures, they're all connected. Okay, the very objective of showing this, 1 minute, where exactly, yeah. The objective of showing this is to tell you that one where test procedures, etc., right, they find its position in entire product development. That's what I'm sharing with you. Okay, nothing other than this, right? Then when you talk about the software, it's a collection of computer programs, procedures, rules, associated documentation, data. Okay, all these things together, it makes the product. Got it? So you need to understand, and testing has its own position in all these things. Let me introduce some other terms, right? And if people know about that, software development has been and is and remains hard always. Why it remains hard? Because of the complexity. If people think that one, right, with my intellectual capability, I can manage all the things, right, that's very difficult. So it becomes unmanageable. My colleague Govind is here, is part of the software development team, right? When a software grow, it becomes complex. You cannot manage it. That's why documentation is necessary, right? That's why systematic working plan is necessary, right? Otherwise, you get confused with whatever that you don't understand whatever you have done it, right? Yes. So these are all part of deliverables. All right. So now let me not tell you about this, which part of the software engineering. Now, when you look at the rational unified process, right, you find, I'll show you where did I put it here somewhere, 1 minute. Yeah, when you take a rational unified process, the software testing finds its a position from the first phase, ideation phase, requirement phase till end, and you have four important phases in a rational unified process: inception, elaboration, construction, and transitions, right? Which already we have covered. Leave it. Then different software development model, we have covered it. All right, leave it. Not much interested about that. We told about the complex software's different nature and all. We told about the quality factors and all we discussed. Yeah. Now look at that effort distribution. If you look at the effort, requirement 10%, design 20%, coding 20%, right? Testing is 50%. Okay, when I say about the effort of testing is 50%, it should not be understood as a separate, isolated entity. This testing is a part of requirement, part of design, part of coding. Okay, testing doesn't occur only as a part of coding. No, right? That's why Pankaj Jalote, I think probably if I'm right, I've taken it from Pankaj
Human,
Jalote.
sir.
Please.
Sir, I think you are not audible, sir.
I'm not audible?
You are unmuted, but
Hello?
Audible.
Audible now? Hello? I'm audible?
Yes, sir.
Okay. In between, immediately you tell me if there are any such problems, right? Okay. Now, when you look at that here, testing we said 50%. Okay, it should not be understood that 50% is a isolated entity in product development. This is the integral part of effort. This is integral part of your requirement engineering, your design process, your coding process. All together, it is put as a 50%, and testing as a separate entity also. Right? But what is the meaning of this? And this I've taken it from Pankaj Jalote. There's also a nice book on software engineering on the top of Somarvale. You can refer. And Pressman is another book. These are the standard three books which always you can refer. And when you look at the effort allocation, right, 40 to 50% efforts, front-end activities, customer communication, analysis, design, review and modification. Okay, 15 to 20% construction activity, coding or code generation. And another 30 to 40% testing and installation. There are different kind of testing that gets into. This is theoretical stuff. I told you about that. Today I'm sharing with you all terminology, theoretical stuff and all. Probably, right, from the next class, the concrete things will begin. You can find these things available, right, in the internet also. Right. Maintenance also, we said about that, corrective maintenance, adaptive maintenance, perfective maintenance, the different terms being used by different people, right? This okay, corrective maintenance, the known fault, known flaws, you release it, do corrections. We discussed a lot on that. Adaptive maintenance, any change in the future and all, right? Any change that you introduce, right, is going to add a bug into the code, and the bug, okay, does code, like a new code, whatever you added, might disturb the existing correct working code also. Then you need to rerun the existing test cases so that the existing features are also tested along with the new feature which you have added, right? So that's why one of the important design principle is that how do the impact of the change you restrict within small area, right? And that's what we say an abstraction, right? Please remember abstraction, or you call class, or you call an object. The very purpose of that is to enable maintenance. Don't tell abstraction is for. I think we have discussed a number of times. The very purpose of an abstraction is to, right, ensure that the outside world interact with this internal things through only interface, thereby you are thereby enabling code and design maintenance. Please remember it. But and you can enhance better reading, better design understandability, better maintenance. Why? Because you have a highly cohesive, right, abstractions available to you. The abstract class, right, or abstract data type, or the class. Look, there are different flavors at different levels you can see, right? Abstract data type ADT, right? Class is the representation of ADT, right? Objects are nothing but implementation of ADT, and very purpose of all these things is to, restricting interaction with outside through interface only, so that any internal change you do, the change as a part of an adaptive maintenance or the corrective maintenance, right? As long as interface remains same, right? It doesn't have an impact on its surrounding, and this is the advantage. This is the benefit advantage of going for abstract data type, right? So this enables code maintenance, and all these things we have discussed in length in previous many classes in all, right? And very thing, software industry gained a reputation of not delivering software within schedule and budget. Govind, right? Producing software system of poor quality. The reason is you cannot manage complexity. You are not disciplined one. The documentations are not okay, right? Okay, for example, database. Like if you have one table, two table, you find very comfortable. 4 table, 5 table, oh, you can manage 1%. 10 tables and all you can manage before people are that. When it becomes a 40, 50 table, right? Understanding its relationship among different tables and all, it becomes very complex. Govind. And that will make you not understand the things, not read the whole your design product design properly, and thereby that becomes a cause for your failure. It is not that you can't do. You can do, but small thing you can do. All human beings, we have a limitation, right? A simple example I used to quote, assume that you are preparing upama. In North Karnataka language, we call upittu, upama. Govind is very expert in that. Correct? Very expert. You can ask him to, prepare once. He teaches, that better than IoT. He prepares that. That's what we heard it, right? Okay. Now what happens is upama, if I ask my friend Govind to prepare upma for 2 or 3 people, fine, very good, nice thing he can do, maintaining time, right, maintaining quality, maintaining features of that, serving, okay, all the things. But if I ask him, like, Govind, can you prepare for 2 people? Yeah, certainly, very nice. But if I ask like people upama or this one for 200 people, then the quality, delivery, whatever he do, it will degrade that one. Because he does, I mean, in the sense we all people don't have a capability to manage a complexity in terms of large scale, right? That's why working in a team, that's why working in discipline kind of things is necessary. This is the fundamental aspect of, okay, why testing, like this. There are many things, right, Levitt? This is what I don't want to speak about that. And also, please remember, when you look at the requirement specification, software requirement, you find that there is one statistics okay, quoted by Pankaj Jalote, right? He was there in Infosys. He was heading the Department of Computer Science and IIT Kanpur, right now I don't know. He's one of the data sets speaks about that, right? The requirement 26% omission you find, 10% incorrect fact, inconsistency is 38%, and ambiguity is 26%. They become a cause for your root cause for your errors, your faults, right? This is fact. And also he says that one software okay, industry has established with reputation of okay, software failures, almost everything. That's why people put a lot of effort in the process, right? Yes. And please remember, when you look at the microscopic level, what is the product? Any product you take, it simply maps input to the output with the transformations, right? And in this diagram, look at that. If you are unable to locate one of the possible input while designing, while coding, possible input, and is not taken care as a part of your design and coding, you don't know what output it is going to produce. It may produce horrible output. For example, if age is greater than 18, issue, right? License, right? If not, then what software has to do? If you are not clear about that, then software, it is something else. Okay, may happen in the software. Got it? Probably, if it is less than 18, right, probably you want to terminate that one. Okay, if it is not being taken care properly, that's what is a diagram that shows input causing erroneous output. If this input causing erroneous output, this is erroneous input because no input that causes error. This is because it is not accommodated in your design, and hence and therefore in a program, right? Yes, that's a very simple thing. You people have to understand it. So the possible input, that's what in equivalence partitioning I spoke about that, right? There the possible input is one is okay greater than one partition P1, partition P2. Two representatives are necessary to show that program doesn't have a fault, right? And remember, software testing is a negative attitude. Though it's not being said, right? There, showing the fault is very easy. The moment you get one fault, you can say product has a fault. But proving that product is working correctly, it takes your infinite time. Am I right? You cannot prove that your product is correct, but you can show that there are faults. Hope you all people understand the difference between these two, right? Simple example to quote in our day-to-day life, in order to say that we are human being, until our death, we have to show that when we are pure, correct, we have a good character, okay, we are human values and all, good. Okay, just one fault, go and slap somebody in the street, you become a bad. That's the end of that. Okay, people add a bad okay, brand to you that one, he is a wrong person, right? Are you understanding that? Testing is like that also. You try to find the fault there. Got it? You cannot show that one. These are totally free from all the faults and all. No, sorry. Right. Distribution of error, you know about that. When you look at the error, I mean, that's why testing comes. In requirement, 20% error occurs, in design 30%, in coding 50%. So accordingly, testing is also goes into requirement, design and coding. how do you test the requirements? Govind, how do you test the requirements? Simple thing, you take one requirement R1, right? It should read input and produce sorted output. Govind, little bit you can listen here, right? It will take integer input, right, and produce, right, sorted output. Fine. Look at that. There is an ambiguity in that. What is sorted output? And as an analyst, you need to tell that one, it should take the minimum, it has a capability to take a minimum of these input and maximum of this, because probably it has a capacity to take 100 input only. If it only do 200, it fails. You need to be very clear about that. That's what is the requirement. Requirement R1, right? It takes maximum of 100 integer. Right? Second input, it produces, right, sorted output, okay, based on user input in either in ascending or descending. Third one, for ascending, capital A is to be inputted. For descending, right, capital B is to be inputted. In any other case, it should display that one, the user input is incorrect. Are you getting this? No, this has to be stated. You cannot say that one we can know. We assume we are okay, teachers here, we got design experience, we are developers here. No. Requirement is requirement. Until unless you mention about that, right, there is no clarity. Because now look at that, I'll say that one you should produce a software output. Fine. When you produce, and people say you assume that you are increasing order because you are working as a teacher here, you will be always in increasing order, but user wanted in a decreasing order, or you wanted a flexibility. You are not as analyst interacted with the then actual requirement. Okay, this is called omission. Right? You omitted that part of the client's mind, and you cannot blame them, right? Because you are an engineer. So this kind of flaws get into how do I do testing? Here there's nothing like a script writing involved. You take that input, I can make the customers also participate in that different level, and you have a different role to perform. There is somebody leader, and ask everyone that whether the understanding of that one is same for all the people, and you keep on interacting with that. But what kind of output you wanted? Is it only sorting? And if all people have the same opinion, then you take it. That's how the requirements are being tested correctly. Are you getting it? Are you getting this error? Wherever error is there, you need to test that. Testing has a different strategy. I'm not testing the code here. Arpita? Ashish? Making some sense?
Yes, sir.
Okay. Now look at that. You need to do that. You need to test that, and you need to do the corrections there. If you do not correct that one, anything at the requirement phase about the requirement correction, if you don't do, right, assume that Govind has not corrected that, taken to the design development and all, and he comes back and demonstrate after Deepavali, and I'll say that one, okay, you are producing ascending order, but I don't want that. Then what Govind has to do? Govind has to say that one, use this Kulkarni, what is that you are doing? That's all. I'm a customer now. Right? And the thing is that he cannot blame a customer. Probably as an analyst, he has not performed his work properly. Right? Are you getting this? So you have to undo that and you have to pay for that. Okay, and whatever you have done is a waste, and you have to redo that. That will increase the cost of the product, or that will reduce the profit margin. Right? Because that much of time you are wasting. Right? So it is true with your also. Okay, you are in the 5th semester, study now properly. If you don't do that one, and when you go to 7th sem or when you join industry, you cannot come back to the 5th sem and study this. Got it? So in your lifetime, every age, every slot, every time stop has its own expectation. Right? So you have to do that. During Deepavali holidays, you have to enjoy. You should not read separately anything. If you don't do that, if you do not enjoy the festival, this thing, you will miss important part in your life. And when you are playing, you have to play. When you are reading, you have to read. You are getting it? Right? And no interlinked operations. When you are reading, you should not think about IPL. When you are watching IPL, you should not think about software engineering or IoT. but you should have a priority for that. Time allotment. It is not that an operating system scheduler equal time for all. No, right? The interaction session is getting closed in next 2-3 minutes. Until that, I proceed and then stop. All right. Leave it, leave it. There are two terms that we use. One is detection and another one is prevention. These are two different terms that are being used. For that, there is a standard story is there. Policemen on the riverside. I'll tell the story. When stops the meeting automatically, that's the end of that. So there was a very weak beach, right, on the top of the river. It may collapse at any time, right? All broken things are there, right? People were walking during the night from here to the other end, right? Now there are two approaches. People may fall and they lose their life. So when you talk about the detection, right? What people do is, if people fall, you listen the sound, big sound, then employ the great swimmer, right? Then rescue them. This is detection. You hear the sound, then ask the swimmer, rescue them. Detection. The similarities in software also. Then prevention is the best thing is that you put the light there so that people know which particular wooden piece is broken so that they do not keep their leg there, it fall right in the river so that they can go keep the light there. And regular maintenance. Regular maintenance. Declare one day holiday in a week and check all the wooden plates put on the bridge and all, check it, right? And many times, this is called prevention. So that you will not have to employ a great swimmer and pay them huge salary for that. So in the life also, you need to prevent a lot of things rather than detecting later. See, cholesterol, you should not eat oil, junk food, pizza, burger and all. It's not good for health. No, let's eat. Right? Whenever problem occurs, no, then we'll go for the doctor. The doctor will heavily charge for 5 lakhs, 10 lakhs and all. Why do you do that? Now you can prevent very well. Now have a very disciplined food. If you want to prepare a pizza, prepare it in your home. But that is once in 6 months, not every day. Once in a year, all right. Not every day. So you can restructure, reshape your food habits and all. You can prevent all kinds of things. Morning, get up early in the morning, do exercise, activities, clean home. You don't employ your worker there. Sweeping floors and all these things. You do it on your own. Cleaning utensils, preparing, cooking food and all, right? Rather than going to hotel and purchasing every day. Prevention. Detection is whenever you have a disease, go to doctor and pay heavy money there. Right? This is the two important things that will influence product. Quality comes from both. Both detection and prevention, both are required. Right? The different dimensions of that, I will share with you. Now look at that in this one, right? We have very interesting thing. When we go heavily for prevention now, it is right, heavy process oriented things. I don't know the automobile, which automobile and all. They put heavily on the process. They do not test the vehicle at all. They release into the market. Every product vehicle, I'll collect that one, recollect the name of that and I'll let you know the next class. Heavy process oriented so that every process produces good results. They don't do the testing. Release the vehicle in the market. None of the vehicle has a fault in that. But heavy investment, that's what you find the lower quadrant here. Right? Heavy, high, prevention and right, low